in Karlsruhe. He is carrying the diploma of computer science. But early after his diploma, he went over first to Canada and then to the United States. And since 1978, he's working with IBM in Yorktown Heights in the research area. During his work there, he also made his PhD together with the University of Massachusetts. He started working there on mainframe performance analysis and many other different jobs within IBM, and today he's working on the relation between electronics industry and researchers and the information exchange. So, we are looking forward to your presentation.
Okay, good afternoon. I actually had a similar keynote role at this conference a little bit earlier this year after the Consumer Electronics Show in Las Vegas, and to see one or two faces of people who were actually there. So do not fear, this is a different presentation. But this is actually, as I said, Scott, my colleague, has prepared a lot of this, and unfortunately he can't be here, so I'm going to be presenting that. Okay, so this is about the service delivery to the smart home. So what we're seeing is that with the internet connection to pretty much all of the electronic devices, a lot of the manufacturers are looking to move from a pure product business where there's a lot of commoditization going on. That is, it's very hard to differentiate the products purely on product features. They're moving into services business. And so what you're seeing here is actually sort of a number of examples of the kinds of services. So you have things such as energy management, you have appliance automation, you have entertainment. That is, it is almost impossible today to actually buy a television that does not have an internet connection. And then you got things such as other services that you can provide from a home automation perspective. What we're looking at actually here at the bottom, you see this is where we see the major four areas, where the applications are coming from. That is, this is entertainment and convenience. So obviously everybody probably has seen internet television, but it's also convenient in terms of home automation, in terms of access to your home via your smartphone. Then there's energy management, which actually is also becoming more and more important. For instance, there's we're prototyping ways, and we're actually working with utilities and with appliance manufacturers to make the start and stop, the scheduling of your of appliances, to make those essentially driven by the energy price. That is, to start your clothes washer only when the energy is lowest. Safety and security, obviously, safety, this is not just essentially protection against thieves, so to speak, but one of the applications that we're actually seeing a lot is that when nobody's at home, when both parents, let's say, are at work, the children are coming home from school in the afternoon, we find out that parents are actually extremely interested in finding out what's going on in the house. So having a webcam in the family room, then they can check, for instance, whether children are actually doing their homework. Turns out we've talked to a number of suppliers to those services. That's an extremely interesting and very popular use case. And then health and wellness, this again is not just like the medical, the hospital kind of things, but can actually have a friend of mine has his weight scale connected to the internet, and so he can actually then track his weight, and that also shows that security is extremely important for this, because he doesn't want to know everybody else how he yo-yos with his diet. From a business perspective, we expect that by 2015 we will have actually the billions of devices, and if you look at the charts at the bottom here, the blue parts at the bottom are actually entertainment devices. but the green the green part is actually non-entertainment installed base. So this is various projections. So this is a very, very large scale development. We've also found out that consumers are actually like this. That is, we conducted various surveys, and that was actually, this particular data is almost 2 years old now, where at that point already almost 80% of the consumers had some wireless broadband in the in the home, and the most surprising factor to us was that people were actually willing to pay more for connected devices as long as we can make it clear to them what their benefit is. But there were enough people who recognized those benefits that they were willing to pay more. Again, at that point, and these numbers are actually coming from the US West Coast and US East Coast, so this is actually not from the center where I guess things are a little bit drier. But at that point, the average of connected devices that we found were in a household 6.3. If I look like, just what's in our household, we're probably sitting somewhere at 20, but as I myself probably have more than 10 already. So there's an explosion going on in terms of the connected devices. Here, again, this is about the different kinds of application areas where we're looking at. So web-enabled TV actually turns out is the top application. And if you go around, for instance, to all of the television manufacturers here, you see that now again a lot of them actually look at the connection, at the services that they can provide as one of the big differentiation capabilities. I have not actually been. I looked at the Samsung Hall, for instance. I somehow didn't even manage to keep track of all of the different kinds of services, different types of things that you can do with those televisions over the connection. So there is again a huge explosion here in terms of additional function and additional benefits. Now this is sort of an interesting chart because most of the time people look at the top as what's the thing that's most important. But what we've decided actually an interesting point is the bottom. That is, where is the biggest scope for improvement? That is, where do we need to put more development in? Where do we need to work harder to make it happen? And so we found out that actually the linkage to the service provider and the quality of that link, and the linkage to the device manufacturer and the quality of that link are actually where we see that people that we've been talking to see sort of the biggest need and opportunity for improvement. And to give you some kind of an idea, for instance, when something breaks, well, we hope that happens still under warranty, then you often have to crawl behind the machine, find the model number, find the serial number, then you need to go to the phone. Maybe the phone is not exactly where where the device is, and then you sort of run between where the phone is and you're maybe in some cases actually if you have a mobile phone, hopefully you can be directly in front of your device. But these kinds of service actions actually have a tendency to be aggravating, and this is also where I think there's a huge potential. There's a huge potential for improvement. For instance, if then the service provider or the person in the call center that answers the call has actually direct access to the connection, then they don't need the model number, they don't need the serial number. They can actually interrogate the device, they can find out what the version of the firmware is, etc. And so we believe that there is actually, by having those interactions, there's a large benefit ultimately for the consumer, because it makes any kind of service simpler for the consumer. At the same time, and this also now has to do with the financial aspects of this, at the same time it makes it also creates a cost reduction for the manufacturer. That is, in the United States, for instance, an average appliance repair requires 1.9 visits to the home. That is most of the time, overwhelming part of the time, the person who comes for the repair doesn't have the right part or doesn't know how to do that and has to come back. So if there is a way for the manufacturer to reduce that number to maybe 1.2 or 1.3, then the warranty costs are actually going to be substantially lower. So there is obviously, then it's either lower cost for the manufacturer and or a lower cost of the warranty for the consumer. So those are all benefits actually that are driving the development. So here is just a number of companies that we're working with. CABA, here this is the Continental Association for Building Automation. This is a group mainly in North America, but I think they're also starting to branch out. In fact, I told their CEO that it should really be the Intercontinental Association. And what they're looking at, they're doing a lot of research of what consumers want, and you can see some of the members here that actually worked with them. Here are some of the latest data that they showed. So these are surveys from the United States and from Canada. And the arrows here actually represent the cases where there was a substantial increase since since the prior term, and it also shows for those who find the connected home not very appealing, this is still what would actually convince them. So looking at these arguments, we can actually see what are the problems that we need to solve to essentially sort of create those services. Then here is sort of again, this is from the survey, the very, very large-scale customer survey that they did in the U.S. What are the things that matter most? Remote control from anywhere. Energy bills is actually surprisingly high. If we actually purely from a business, from a financial perspective, look at that, at the actual data, it's very, very difficult to make the case that the additional investment that is needed to support the energy reduction, that actually sort of justifies then financially what the energy reduction is. So this clearly actually expresses that people, in some sense, are willing to pay for being green. Safety and security, interested for everyone, and it turns out easier to control. Most interested in this case actually are more the men, whereas the remote control from everywhere, and also remote essentially viewing from everywhere. For instance, this example that I mentioned earlier about making sure that the kids do their homework when they come back from school. It turns out that that was a kind of a use case that was more popular among women. Okay, then now here was actually distribution of across the different across the different stages of life. That is, if you look at here, for instance, security, actually surprisingly among the young set seems to play a big role, but it seems to increase actually as people get older. Then access to entertainment. In a sense, what we're seeing here is it's taken already as a given that you can do that. That is, now it didn't actually really bubble up, but we found that the actual use is really really quite high. So, as I said a little bit earlier, we see sort of mainly four sort of areas where it's possible to classify the applications in four spaces. We've got entertainment and convenience, we've got safety and security, energy management, and health and wellness. One of the things, actually let me see, okay, I need to go here. I don't like it when they have these additions because you never know when it pops up. Okay, so what we're telling a lot of the companies, okay, you need to look at where your popcorn is. So what do we mean by that? It was years ago, the movie theaters found out that really there is only so much they can charge for the movie tickets. And so they said, okay, what are the kinds of things that we could offer to people that actually would make the movie experience more enjoyable? what are the kinds of things that people want to do, because often actually you don't just go to movie theater to see that specific movie, but it's an evening out, you want to enjoy, you bring a partner, it's really a whole entertainment experience. And so the popcorn that they're selling is sort of here like the symbol of what are the other things around the core that you can do to essentially enhance the experience. And so if you look at it here, it's really not just selling televisions, but it's actually providing personalized entertainment. That is, you see what you want to see, when you want to see it. And then you essentially augment it. For instance, advertising sometimes is sort of viewed as a nuisance, but on the other hand, if the advertising is targeted in the sense that it corresponds to your profile, then probably it is less aggravating. For instance, my sons are 18 and 21, so I really don't need any diaper advertisement when I watch television. So those are the kinds of things where you actually can essentially, even from a consumer perspective, remove the aggravation, but also obviously from a business perspective, in a sense, who pays for this to make it available? By getting targeted advertising, actually, you don't need to watch so many ads. Or in the case of cameras, it's not just a piece of hardware. What people are looking for is creating and sharing the memories. And if you look today, you can actually buy all kinds of cameras that have an automatic connection where you can upload your pictures to Flickr or some of the other websites. So the point here again, for all of those things is, look at the experience, what the user wants. What is the purpose that the consumer puts that device to use? And then once you understand that, then you understand also how can you sort of improve the enjoyment, how can you improve the attractiveness, how you can improve the ease of use. And so actually somebody suggested last year that they really should change the name of the Consumer Electronics Show to Consumer Experience Show. That is, this is really what consumers are after and are paying for, and in some sense the devices that we're all working on are only sort of, a way station to get there. Another aspect of this is actually as the products become smarter, and as in particular as they become connected and we understand the interactions, they generate a massive amount of data that again, can be put to all kinds of use. I mean, this, what we're seeing here, this, intelligent, interconnected, and instrumented, this is actually, these are the three major components that IBM views as being the foundation for a smarter planet. And the instrumented and the interconnected is, in fact, what the electronics industry is providing. So the electronics industry, in a sense, is actually foundation for the smarter planet. What actually IBM does typically, we do not work so much in the devices, consumer devices, but we're there to provide the services to the connected devices. That is, we've focused actually more on the intelligent piece, and to give you some kind of an idea, is the research division that I work for. We have a little bit more than 300 mathematics PhDs that are actually mostly now working on sort of analytics, on optimization algorithms for all kinds of business solutions, including consumer. And what we're seeing here is, for instance, you get the usage history, demographic data, points of event feedback. So part of the data is obviously aimed at helping the manufacturer provide more information about the consumer, more information about what people want, information, for instance, about what kind of devices should they do, what is the next version, what kind of function should they would they want, including marketing, such as, okay, what kind of devices are people buying in what kind of geographic areas, what kinds of countries. So there is a large amount of information that actually is there, economically extremely valuable. But at the same time, as I earlier said, for instance, we can actually substantially reduce the warranty cost. And to give you just one kind of an example, we had with one customer that was in the area of connected televisions, the registration rate went from 5% when people had to sign up their registration card to now in some countries more than 80%, more than 80%. And so what that means is actually the manufacturer has a relationship with the consumer. So from a business perspective, this really changes the way the manufacturer works. In the old days, so to speak, the manufacturer simply created their devices, put it in boxes, and then send it into the retail channel. And then at that point, most of the time, that was the last thing they heard of it. But now they're actually getting those data, getting the feedback, and so that helps them to do a better job the next time, and also I think helps a lot with marketing. But the other aspect is, and as I said, now we actually can wrap services around. That is, and the services are effectively what enhances the experience. That is, a lot of the time, services really create the experience. Some of them are fairly, simple. That is, you can do device monitoring. You can actually find out when it breaks, and then maybe do real-time software upgrades. But you also can download additional services. That is, for instance, if you have a smart TV, you can live download new applications. We find that co-development, and in particular in the area of entertainment, the linkage to social networking, where is actually an extremely powerful and extremely popular kind of a feature. And the other point is personalized content. That is, actually I can express my preferences. The system may actually recommend things to me because it knows what my history is, and then using social networks, the system may actually know what my friends like. The system may also know what people with my profile like. So you actually get additional suggestions of what you can do with your device. And so the services, I think, are an extremely interesting part, both for the consumer as well as for the manufacturer, because they offer the manufacturer essentially an escape from the commoditization. I'm not sure how much you're sort of typically familiar with the business side, for instance, of the television business, but it's actually, if you just look at how the prices decay, over the last several years, the television business has become very highly competitive, and it is extremely difficult for the manufacturers to create a difference solely by the device function, even though if you walk around the show here, you can actually see they're all trying really hard. Okay, so this is sort of actually a big picture of where we see things are evolving in the future. We have the smart home, and so while the television is part of it, there's a lot of other devices that are in the process of getting connected. Things such as let's say a smoke detector, fire alarm. You have maybe some of the medical devices, obviously air conditioning, lighting, appliances. Computers are already connected. Some of the high-end cars that you can buy today already actually have a 4G network connection that is built in, that comes right with the car. You get the utilities, you get the locks, refrigerators, mobiles, you get all of this. And in some cases, manufacturers are highly specialized, but I've talked to one manufacturer at some point. They said, we make one of every of these things. Now, it's not just that each of those devices are connected, to the cloud. It's also that they actually can talk to each other. And there's a lot of benefit from having them talk to each other. To give you one example, let's say I'm sitting in my entertainment room, I'm watching a football game, or if I'm in Europe, I'm watching a soccer game, and the front door bell rings. Well, it's just about to get a goal, and this is a really tricky situation. I don't want to get up. So I can now push a button on my remote control, and I get a little picture-in-picture from from the webcam that I have in my front door intercom, and I see actually maybe it's just somebody who wants to sell me something. Okay, forget that. On the other hand, maybe it's actually my friend, and then I push another button on my remote control which opens the door, and I say, hey Charlie, just get a beer, come in, it's really interesting. Other things, in the home, for instance, might be, and then that gets to the second point. Let's say I have all kinds of detectors, from a smoke detector to carbon monoxide detector to front door and window sensors to, let's say, a moisture sensor around the clothes washer. And now my home insurance actually says, Martin, if you give us access to those, if you let us monitoring, I'm going to give you a 15% reduction on your home insurance rate, because we can actually sort of reduce the probability of damage so substantially that part of it we're going to give you a reduction, and part of it obviously is going to go to the bottom line of the insurance company. But it is important, once we're connected here, we do not believe that there's just going to be sort of an individual set of isolated services, each of which has a connection, each of which the consumer has to subscribe to, each of which is going to get another home gateway in the system that needs to be managed, each of which is going to get him another bill every month that he has to pay, but rather that we have a platform. That is a platform where ultimately all of the devices can connect to. And then in the cloud, we have the services, because one of the things that we don't need is more complexity in the home. That is, I already have to manage 4 laptops, from my family, which I think is, from my perspective, is as much work as I really need. So if I have a home gateway where I can download applications and I still need to manage that, I think very few people would be enthusiastic about that. So if we can manage the devices in the home from the network, and then get a lot of the services such as the analytics and the service provisioning in the network, we take a lot of the complexity that is increasing incredibly. We can take that out of the home and move it into the cloud. And at the same time, then we have on the other side, there's a platform where by having this universal access to a very large number of devices and a large number of service possibilities, we can offer service providers from all kinds of other walks of life access to use that infrastructure, which, if they don't have to build it themselves, is actually much lower cost. And so creating this actually creates for the service provider in the center an interesting thing that we call a two-sided business model. That is, whoever provides the service can actually provide the consumer services here, but at the same time rent out access in the platform to third-party service providers. Like in practice, from the way we're talking to people, for instance, there's probably no phone company in the world that is right now not looking to actually build a platform like this. So this is something that over the next couple of years, we really believe is going to happen big time. Okay, so what do we do about it? It turns out that over the last several years, we have in the telecom space developed all of the kinds of support that is needed to provide services. So here is the innovation, how we can quickly launch new services, and the actual operation is what we call a service delivery platform. So you have creation, execution, and management. You can link to third-party services, because typically that platform operator in the center that we saw earlier is not able to provide all of the services. And for instance, let's say in the United States, if I get, let's say my service provider, Verizon, well actually, I wouldn't trust them for insurance. So for insurance, I go to my standard insurance company, or for let's say security, I go to ADT Tyco, that essentially have an established track record. So linking to third-party service providers is important, and then the monetization, that is OSS, BSS, those are actually terms from the telco industry. This is the operational and the business support system. So this is actually where we integrate and manage the business. And what we've done then more recently we have taken that platform that we've developed for telco, and that actually in the single largest operation, we use that to manage 200 million cell phones. Some of them dumb, some of them smart. We manage everything around them, from provisioning to device management, to selling ringtones, to giving people commercial offers, to SMS, to whatever. We took that platform, virtualized it, and put it into the cloud. And so the bottom two layers is actually now that we've created a fixed package on top of which we can offer services. Any kind of application services here are like the four that I've talked about a little earlier. And another aspect of what we're doing with this is actually working in terms of the business model of our partners. That is, we're not going, let's say, we actually announced with TP Vision, which is the television arm of Philips. We just announced that we have actually a service for them on top of that platform. We're not telling them, hey, here's a pile of hardware and it costs this much. Then you have to license that software, and then you have to license, service people who put it all together. And then it's up to you to figure out, is that really going to be profitable, or how does it scale into the business? But with those folks, we said, okay, the contract is in terms of connected device per month. So that actually means what we're providing here, and this I think is a general trend for a lot of those services. What we're providing here is a business service, not a technical service. So we believe that this is a trend that is quite powerful in cloud computing. That is, it's not just providing virtual processors, virtual memory, virtual storage, and virtual networking, because if this is the only thing you do, then the consumers of those resources have to add in scalability, reliability, security, all of those things that are actually, all of those functions and attributes that are much easier to do, to provide if you build them right into the system. And so that's why we actually built that package as a cloud-based package, which then also means we can start out very small with little resources, but without architectural change, can actually grow quite large. And as I said, at the high end, we've got some really big installation of the service delivery platform, but in the low end, we've started with 50,000, 100,000 devices. So this actually spans a gigantic range. This is a little bit more about how the software infrastructure looks. So on the one side, we have all of the parts that have to do with the service creation, from collaboration to concept to testing. Then the services themselves are run in an area that we call, this is the service integration, but they can use a lot of common functions such as presentation services, commerce, subscriber management, device management. So there's a lot of function there that if you develop on this platform, you would actually not have to implement. Service choreography means we can actually string multiple services together, such that if you have different piece parts that together provide a service, are reasonably easily connected. Then there's the connection via web service interface to third-party service providers. And then here we've got sort of what we call the backend system. And then that section down here is also really quite important. It's the master data management, but particularly also looking at what we're doing with analytics. So this is an example of smart TV, where actually people, in addition to the standard linear broadcasting, look at all kinds of services. As I said, this is a service that we're working together with TP Vision, which is the service arm, the television arm for Philips, and to see sort of a wide range of services. In fact, we just had a meeting with them. The number of services they can expect in the future is even going to increase. So from a financial perspective, okay, well, do we really want to make consumers of the television pay more for services that they may or may not use? Well, we don't. And so what we're actually seeing, that the services that we're wrapping around these devices, and again, this is a television example, but you actually can apply that to pretty much any service around connected devices, if you build those services right, they essentially fund themselves. They're sort of a business on themselves, even though they're part of the overall package that the consumer sees. So in the case of a television, for instance, you can do placement fees. That is, that certain content providers actually pay to have their services shown in a prominent way. We all know this from the Google sponsored results, but you can do that also here. Another point is click-through fees. Then for VOD, for movies, that is for people who actually have a pay service, you can do revenue share. But one of the big revenue generators here is actually the advertisement. That is where there is an advertisement on that portal. And since the television knows, in this particular case actually, the television uses web technology. It uses a technology called Consumer Electronics HTML, CHTML, so it's a browser and the television, while the browser has cookies. And so even if the user has not registered it, then when that television connects back to the service, we always know it's the same television. And so you actually can develop a profile and then get targeted advertisements. Another example that was actually done at our laboratory in Böblingen as a pilot project, this is an interconnected physical therapy system. So let's say a physician here prescribes some physical therapy, the health insurance improves it, the therapist decides what's needed. This is all sort of managed and stored out of the service delivery platform, and then the patient has to do the therapy. And so what we've got here is actually then a way to help them. So we're using a Microsoft Kinect, which you can see here in the center, to monitor what the person does. And because there was an initial practice that the therapist initiated, you can actually say, well, Martin, don't flap your wings. You really got to move much more smoothly up and down. That is actually, it analyzes whether the people doing the exercises do them right. So you see here at the on the left side of the television here, you see the green bars. That is, if the arrow isn't there, some kind of an indicator, the person doing the exercise is doing right, and essentially translated from the Kinect, you get the avatar. That is, so he'll actually see exactly what he's doing and what the device sees. Down here, we see actually the number of repetitions. And so if, for instance, you can use this, for physical therapy, you can make sure, number one, that the people are actually doing what they're supposed to do because it gets connected. But at the same time, a larger portion of the physical therapy can be done in the home. So it's much more convenient for people. They don't have to drive that far and don't have to spend the time. They also can do it when they like it. But at the same time, there is enough of a supervision there to essentially record and detect when sort of things are not really quite right. That is, when the exercises are not really quite right. And then the physical therapist may actually give the person a call and say, hey, you really, maybe you want to come in to practice those moves that you're going to do it better the next time. So those are, this is something, for instance, what we can do in health and well-being. Another area is actually, this is a commercially available product, but people have an armband that looks at, I think, 6 or 10 or something like that, variables where it can find out, let's say skin conductivity and others, and based on that, it understands what your calorie consumption is, and then it feeds back in the system and looks at, how well you're doing, and essentially gives personalized feedback about exercises, about, what people eat or should be eating. Here is another case. In fact, we've sort of had a bunch of proof of concepts. We're working here with a number of companies such as Diehl, the EBB. There are some German companies on the smarter homes. So what you have here from an energy perspective is actually an extremely challenging situation. In particular in Germany, there are a lot of solar panels. So what used to be that the generation is extremely concentrated, it's just at the power plants. Now all of a sudden the generation itself is really widely distributed. And to give you one number that I've heard is that the average farm barn roof generates something like 60 kilowatts when it is set up with panels. Now 60 kilowatts, there are very, very few households who use that much. So they're feeding back into the network. Another number that I've heard in talking to some of our customers today is that in certain areas of Germany, more than 10% of all of the power consumers are also power generators that sometimes or other, not all the time, feed energy back into the network under this regulation that people can feed power in the network and that utility actually pays the money. Now, at that point, I think we've got critical mass. If 10%, or in this case actually slightly more than 10% of the consumers are also producers. Now, as it turns out, our networks, the smart grid, neither in Germany nor in the US nor I think anywhere in the world is really optimized for that kind of system. And so a lot of the efforts that we're seeing in this space is actually first having local controllers that sort of optimize the use in the home. And for instance, if the sun shines and you got a lot of energy, you can actually then run longer freezing cycles on the freezer. And then, when you don't have the external energy, maybe you run shorter cycles because, tomorrow the sun is shining again. So you can actually, in some cases, adjust the energy consumption, to the availability of energy, so you need to get less energy from the network. Other things actually then that are sort of more, require more of a cloud type solution is that you actually understand the energy patterns and that you understand, how you can route and manage the local networks to optimally distribute that energy. Energy management, one of the companies that we work with is Lutron. And I don't know what it is, it's jumped in its own, but it's okay. One of the things that they do is actually, we didn't really quite want to go that far yet. One of the things that they do is for large buildings, and they demonstrated that when I visited their plant a little while ago in their cafeteria. They do an integrated management of all lighting and all heating. So in a room like this, ordinarily the lights that are close to the windows would be really dim. When it's really bright, they wouldn't be on at all. So in their cafeteria, the lighting directly next to the outside windows were off. And obviously further away from the windows, the lights were on, and you could actually see sort of there was a transition. Now when it gets dark outside, obviously the lights turn on automatically. And they found out in commercial buildings such as, maybe hospitals, or in this case actually it's an industrial, it's a business office, you can save up to 25 to 30% of the energy by optimally managing the lighting together with the outside, lighting. And then obviously when nobody's in the office, you don't have to have the light on at all. Now, sometimes this can be sort of a little bit of a nuisance because if you sit in your office quietly just typing away, the light goes off. So actually, turns out they have developed an algorithm that is so sensitive that it picks up somebody who doesn't move at all except for the fingers while typing. It still picks that up as, okay, somebody's in the room, they're not allowed to turn off the light. So there's actually, for the individual use cases, from a usage perspective, there's a lot of research needed, and I think one of the things that we're seeing, and it also happens, in my division, rather than being fundamental, doing a lot of fundamental stuff, we're starting to work more and more actually in the use cases, with the specific uses. Okay, I see. Now we're getting to the question and answer section. Okay, so this is actually what we're looking at, building a reference architecture in the cloud to supply those services. That is, I explained this picture earlier. So we're working with a large number of companies that are providing services here for the devices, and they're providing also services here to create an architecture, actually to create that platform where everybody can get on, where everybody can get on, and where you sort of have an easy way of adding services. So we're looking at this. So there's the content providers, there's the smart home platform and the device manufacturers, and so there's some business control points and then technology control points. So on the technology, let's look at it, the gateway. There's a lot of devices in the home are not smart enough to actually really communicate with the cloud. So let's say you have a light switch, or also even your clothes washer may not necessarily always be able to communicate. So in a lot of cases, there's a gateway there. Actually, I think there's a little bit more stuff there than I think I want to go through. So let me quickly jump to a couple more points that I'd like to make. This is actually, I'm going to give this for you for 30 seconds, and then I'm going to ask who from you can remember all of those. Those are all standards associated with the smart home. Or the other question is, who can give me the most examples of home-related standards that I don't have on that list? Because I don't even claim that's close to complete. So the bottom line is we have sort of an incredible soup of standards, that's partly from the different communications networks, it's partly from the different application domains. And so one of the architectural challenges is in fact that we have to understand, we have to accommodate the diversity. So there's a lot of in terms of abstraction layers, that is, if you want to treat, let's say, a temperature as a temperature, so we need to have an abstraction layer for all of the communications that temperature sensors have, and also for all of the different kind of readouts, such that the software ultimately that uses the temperature doesn't have to worry about which kind of sensor is it and over what kind of network does it communicate. Another aspect of this is sort of there's a tremendous sort of condensation happening. There's a very, very large number of endpoint devices. There's sort of substations are in the middle, and then the control center, there's actually a relatively small number of those. So you have this path where the data migrates up, and then the commands for services migrate down. In the middle, we sort of look at intermediate analysis and actions. At the bottom, there are sensors and actuators, which are typically not necessarily very intelligent, but as much as we can, we're looking to push intelligence down. So for instance, a sensor is not necessarily something really simple, but it could be, let's say, a chip for surveillance camera. So that chip doesn't have just the video sensor in it, but it actually has already some analytics in it for change detection and other kinds of analytics, face detection, for instance, simple enough that it's already available in a lot of cameras, so there's a lot of that kind of thing there. And then obviously the communications and then the compression. So some of the sensors actually can be very complex and run full-scale operating systems, but others may not be. And so we look at this kind of a pyramid as part of the architecture. Okay, now there are three sort of aspects, three core components for the smarter home that we look at. So there's the cloud service, you talked a little bit about that, there's the gateway, and then the cloud concierge platform is sort of an interesting development that we've seen with a particular partner that we're working with. So on the service gateway, here are some of the functions from the service catalog to workflow to concierge services, application services. So these are the kinds of services that you see here that a service provider has to be ready to essentially support. And there's, on the service providers, the value-added service providers who can do that, and the consumers, essentially, they may buy the foundational services and then add things as they come and as they're interested in these studies. We don't believe this is ever going to be a one-size-fits-all or a closed kind of system. even though I think some of the people in the market think, a closed fixed function system was going to work. This is sort of an interesting aspect of the analytics that we believe is going to happen. And this is actually what we call big data. Big data here is characterized by 3 V's: the variety, the velocity, and the volume. So in the traditional analytics, you actually store the data in a database, and then you have your mathematical programs run against this. Now, as we look at all of these sensor-based systems, it's not going to work. There's too much data coming in. A lot of it actually is also not really very meaningful. So we have developed something that actually the original name was the distillery, where we're still distilling the data, where we can do analysis for exceptional events as the data comes in. So this is actually what we call streaming analytics, and then only the results actually get stored, not the data itself. So we believe actually for a lot of machine-to-machine, Internet of Things kind of data, there's so much data that we will need this kind of processing. The next one is the home gateway. Clearly, the connection to the cloud isn't necessarily always that reliable, so I will still want to be able to turn the light on in my house when my internet connection doesn't work. And so we believe that most of the time, and particularly if you have a broad platform, there will actually have to be a home gateway, and that home gateway is then the sort of neutralization point. That home gateway creates the abstraction layer for all of the communications. For instance, as you see here, a large number of different communications protocols. By the time the data has passed the communication manager, essentially it doesn't matter what the sensors are, what the data is. The applications and the sort of support services here, they see maybe a temperature, they see maybe a fluid flow, they say maybe individual actions, switching actions, but all of the sort of the specific physical stuff is actually sort of abstracted out, such when I get a new kind of sensor, I just have to write the new piece of the connection manager, but my application still can handle it. And so the final thing is actually, once we have a large number of connected devices, this is the last point. Once we have a large number of connected devices, sometimes I say, my sofa isn't big enough to lose all of the remote controls behind the pillows. So it gets really complicated for the consumer. And so this is a business partner that we're working with that has what he calls a universal cloud remote. So this is, it actually, the simplest case looks like let's say like an iPod. It's a remote control that gets its functionality downloaded from the cloud. So any device that you want to control with it, you can control it. The manual for the device, you can download from the cloud. So, and then he does automatic onboarding. He supports I have already a network with devices. I bring a new one in. Well, actually, then how can you connect that? Well, and connect it securely such that it doesn't accidentally go on the home network of my neighbor. So there are some little problems that we have to solve. That is one of the things that is solved. And the final one is actually that it is a fully functional link to service, such that, for instance, if let's say he applies his remote control to a clothes washer, if something is wrong, he can then essentially, by transmitting all of the data into the cloud, maybe do some initial analytics. If he can't find out with the diagnostic what's going on, then he can actually push a button and he gets a voice over IP connection to the call center person who can then actually help him fix the problem. So I think that simplicity is important, and as there are more devices that are remotely controlled, we believe that the remote control itself may actually be removed from the device specifically and have one that essentially can be personalized for each device through the cloud. But I think now I'm really out of time, so let me just stop here. I think I have time for 2 or 3 questions, but unfortunately I'm supposed to be back at at our conference room soon, so unfortunately I can't really stay very long here. But I've got my email address up at the front, and I can send you a PDF version. And so if people are interested in this, they can get the PDF version of Outbreak. And if you want to send me email to talk more, I'd be very happy to do that.
So, do we have questions from the audience? Yeah, maybe I have one question. So you sketched a variety of businesses, and finally you have a device example that's a little remote. Maybe you can give an example where IBM can have a special, how it can distinguish from other providers, because lots of these services in the cloud and all these things are done by the competition, so there's strong competition in all this area. So what do you think where IBM can especially distinguish itself best from the competition?
Okay, so I think there are two cases. I mean, first of all, I think in terms of actually creating a simple platform which you can sell as a business service, I haven't seen anybody who essentially is that far. Some of the people, I think, I've seen some movement. Another point is, I think, in terms of analytics, by getting this Internet of Things, by collecting all of those data, the analytics, combining the analytics with a service, I think is extremely important. And this is sort of one area, where I think we have been paying a lot of attention for years. Is that we have the people who we used to call the mathematics department. They were more like a mathematics department in a university. Now they're actually called, business analytics and mathematics department, and the only thing they do is actually work on analytics and work with customers. I think that combining that with our service and with our data management capability is ultimately essential, puts all of the pieces together. And I don't see anybody who's got that. In particular, that simplicity thing, as I said, for instance, as I described this universal remote control, that will not work without the cloud. And I can make a final point, but this is something that we can't deliver it, but it's actually something that we're working on. Who has heard about the competition for the Jeopardy game show? Well, not a lot of people. The Jeopardy game show is a game show in the US where people are asked, are given a question, given an answer, and then they're supposed to tell what the question is. And it uses a lot of double meanings, irony, etc. That is in sort of very, very, very complex. So in order to essentially test out our natural language capabilities, we had one of our computers compete. And actually, it turns out it won against the world champions in a tournament of three sessions. And to give you let me see whether I can put that together. This explorer arrived, on, I think, in 1848, we celebrated the 400th anniversary of this explorer arriving at Kapat Beach. Okay, what's the question? Turns out it was Vasco da Gama. And so, if you do a normal search, it looks like anniversary, it looks like explorer, etc. You're never going to find this. But in this case, the algorithm understand, okay, anniversary, 400, okay. If it's 1848, then I really need to search for something that happened in 1448. Kapat Beach, where the heck is Kapat Beach? Well, it turns out somewhere in India. And so then it looks actually with, okay, who went in 1848 to India? So I gave you now already 2 examples. First, it had actually temporal reasoning, and then for the Carpat Beach thing, it actually then had spatial reasoning. If all you do to find the answer is simply, character string matching, you're never going to get there. And this shows you sort of a little bit of the semantic analysis that we've started to do for, by the way, if you recorded, I'm not really sure whether the time is right, so don't hold me to the year. So this is part of the semantic analysis, language analysis that we've looked at. Now, obviously, we're not going to make a business out of, game shows. But we found that this is an extremely hard problem because essentially there's double meaning and there's irony and, there's, there's all kinds of, strange, allusions in those questions. And so it really tested out in a very, very complex case. What does semantic language understanding mean? And so we're actually looking now, for instance, this is a technology that we're applying to the medical healthcare part. That is, we actually have seen some examples already where it's being used for medical diagnostics. But we also are looking, for instance, to apply it. How can we use it, let's say, to do something, let's say, such as Siri, that doesn't fall off the cliff quite as often as Siri does, and maybe actually provides a little bit less humor than some of the answers, that are, I guess, in a lot of cases, involuntary humor that Siri provides. So, those are some of the things actually that we're doing.
So, do we have one maybe final question? If not, thank you very much again.
Welcome.